Let's take a look at some different ways to solve systems. Linear systems are when you have a couple of linear functions. That means if we were to graph them, they would form a line, and they exist together on the same graph, in the same universe. So this x is the same as this x, and this y could be replaced with this because they are the same. Now, I'm going to look at 4 different methods. The first method is literally guessing and checking, I guess you'd say, where we think of it as a number riddle. So the way I might read this is I'm thinking of 2 numbers that add up to be 3, and then the same 2 numbers subtract to be 1. What are the 2 numbers? And you could probably guess and check this, right? Can you come up with them? What 2 numbers add up to be 3, but then those 2 numbers also subtract to be 1? If you think about it, x equals 2 and y equals 1 fit this description. So 2 plus 1 is 3, right? It works in the first equation. And then that combination also works in the second equation. So 2 minus 1, is that equal to 1? Why, yes, it is. So we found a combination, 2 comma 1, x equals 2, y equals 1, that when we plug it in, the numbers work out just beautifully. They satisfy both equations. That's what we mean by a solution to a linear system like we see here. It's a combination of numbers that work. So you could do this by guessing and checking and just thinking about it a bit. It's probably not the best method when the numbers get kind of big. So let's start looking at other methods. Here you see an XY grid because I said these are 2 equations that are in the same system, so they exist together on the same graph even. So I've set both of these up in y equals mx plus b form. Sometimes you get a system set up like this, and guessing and checking this might be really difficult. So why don't we graph the 2 lines and see where that takes us? All right, so you remember graphing y equals mx plus b. This 1/2 is the slope, and the number at the end here, that's called your y-intercept. So you always start with the y-intercept. So the y-intercept was 1. So I went up 1 and put a dot. And then from there, I will go up 1 to the right 2. Always go right if you want to be right. And that was because the slope was 1/2. So my second dot was right there. I'm going to go ahead and draw a line here through that pretty decently, I guess. Not too bad. And there's some more dots that are on the line. Let's look at the second line here. We have y equals -1/4 x plus 4. So which number do we start with? It's always this number at the end. That's called the y-intercept, and it's our freebie point. So we go up 4 and put a dot. Now this time the slope is negative, so that means we're going to go down and to the right in this case. Always go right if you want to be right. So we put ourselves on the line, we go down 1, and then we go over 4. There's our second dot there, and we can draw our line. Now what do you notice about these 2 linear functions, these 2 lines? They have a point in common. The point in common is 4, 3, as you can see it on the graph. That point in common also solves the system. So the point of intersection of the 2 lines is the same as the solution in this linear system. So we've solved it using a graph. That wasn't so hard, right? Now we have 2 methods under our belt. We just kind of guessed and checked. And then the other method was, hey, let's graph the 2 lines and see where they hit. Well, there are some algebraic methods that don't involve graphs where we could solve the systems. And the first one is called the substitution method. Now the substitution method leverages the fact that this y is the same as this y. This x is the same as this x. So one can be swapped out and replaced with something that's equal to that variable. So the second clue, remember our first method, I sort of described them as clues. The second clue says that y is the same thing as 2x plus 7. So what could we do with that? We could take the 2x plus 7 and substitute it in for y on the other equation. So this is how we're going to merge the equations together. So the first equation says x plus y equals 4, and just like in a ball game where you substitute out a player, we're going to substitute out this y. It's going to go away, and what is going to go in there? Well, we need to send in an equal player. Well, y is the same thing as 2x plus 7, So I'll put that in there, 2x plus 7. Now it's simply solving the equation. You notice there's only x's remaining. That means we can solve this equation. So we combine like terms, 3x plus 7 equals 4. We minus 7 on both sides. 3x equals negative 3. Divide by 3. We get x equals negative 1. Well, that's awesome. We've got half the answer. Remember, answers to systems are points of intersection. So what the heck is the answer for the y? How are we going to get that? Well, just plug and chug. Start with the fact that y has to be 2 times x plus 7 according to the second clue. Right? That's a clue, and we have to abide by that clue. So we plug in x equals negative 1 and see what y is paired with that. Remember, we're making an ordered pair here, so there must be a y value that is paired with this x value. So negative 2 plus 7, that's 5. Y equals 5. We can plug that into our answer, and we're done. So this is called the substitution method because I substituted one expression in to the other equation, replacing a variable with that expression. So that problem wasn't too bad. We're going to do one more substitution problem because I wanted to show you how things can get a little trickier and how you have to be careful. You see, I've got a system here. I've got two linear functions that involve x and y, and I see that y is the same thing as 1/2 x minus 3. Now, that wouldn't be too hard to graph, but maybe this equation might be a little harder to graph. So maybe we don't want to do that. Maybe we want to use algebraic methods. So here's how we'll approach this. We're going to take our first equation, which can be thought of as a clue, right? And I'm leaving a little space here because I want to remove this y right here. It's going to go away because what can we put in that's equal to y? Right here. The second equation tells us that y is the same thing as 1/2 x minus 3. Now, I have to put it in parentheses because of that pesky negative 2 in the front that's being multiplied against this expression. So now we go to our algebra solving skills, our equation solving skills, and we just solve this thing. We're going to do the distributive property. Negative 2 times 1/2 would be negative 1x. Negative 2 times negative 3 is plus 6. Now, the other stuff is just sitting here chilling for now. We're going to combine things in the next step. So now we combine the like terms. 2x plus 6 equals 2. We minus 6 on both sides. 2x equals negative 4. X equals negative 2. Negative 2 is the first part of the answer. Okay, so that wasn't too bad. Just remember that distributive property in here and do that very carefully. I like to call this a danger zone where a lot of students mess up a sign or something. Okay, so how do we get the second half of the answer? We go back to one of the equations. I'm going to use the second one here because I can easily plug in x equals negative 2 in there and see what happens. Y equals 1/2 times negative 2 minus 3. Y equals, well, what's 1/2 of negative 2? Negative 1. Ooh, this is working out great, isn't it? Whoever designed these problems really knew what they were doing, right? Negative 4. Negative 4 goes right in there. So negative 2 comma negative 4 is the answer to the system, and I use the substitution method, including the distributive property. All right, I promised one more method. So we guessed and checked, we graphed, we used the substitution method. This method is called the elimination method. And I remember thinking that this was so cool when I learned it in algebra class in high school. We are going to add the equations together because there's something magical that's all set up and ready to go here for us. Watch what happens when we add these equations together. We get 8x plus 0y. Oh my goodness, the y's canceled. They eliminated. They're gone. We're left with 8x equals 8. We divide by 8, divide by 8, x equals 1. Wow, that was really fast. The original problem looked kind of scary, like I don't really want to graph that, and substitution would have been an absolute disaster. But the elimination method, by adding the two equations up, combining all the like terms, the y variables in this question eliminated. This is called the elimination method, or sometimes called the linear combination method, because we're combining these linear functions together to get a new Equation that happens to be solvable because it's only one variable. Now, once you get the first number, how do you get the second one? I get that question all the time. How do you get that second number? You pick one of the equations and you plug your 1 in there, your x equals 1 for x, and you're going to see what y is paired with that, because remember, we're trying to make an ordered pair. 1 comma something is the answer. What is the other half of the answer? Let's figure it out. Let's go ahead and minus 5 on both sides, because 5 times 1 was 5. So negative 2y, don't lose that minus sign, folks. Divide by negative 2, a negative divided by negative is a positive. So in goes the other coordinate here. Our answer is 1 comma 2. You could always use a graphing technology tool like Desmos or a graphing calculator and graph these two lines just to double check that they indeed do hit at 1, 2, and I'm certain that they will. Now, the elimination method can have a little twist, and that's what I'm going to do on this next example. Look at this question. If we were to add these two equations together, would anything add up to 0? Well, let's try it. 4x minus 6y equals 2. Oh my goodness, none of the variables disappeared, right? Nothing added up to 0, nothing eliminated. So we have to go back to the drawing board. We have to go back to the drawing board and do what's called a transformation. So here's what you need to look at, and this is always challenging for students because you have to decide what numbers and which equations you're going to do the following. You look at this problem and you think, you know what, I would really have loved, that would have been fabulous. If that had been a positive 5y, then this would have added up to 0. Or if this had been negative 3x, boy, we would have been in great shape and that would have added up to 0. So we can make that happen though, folks. We can turn, for example, we can turn an x into a negative 3x by multiplying, and it always has to be a multiplication factor, by the way. If we multiply by negative 3, we will get the negative 3x. Don't forget, however, you need to multiply everything in the problem by that negative 3. So plus 15y equals negative 12. I'm going to rewrite the second equation in black because you know what? I'm not going to change it one bit. 3x minus y equals negative 2. Here we have a new system. It's actually the same system, just rewritten. I've transformed the first equation by multiplying all the numbers by negative 3. And you learned in algebra class, if you multiply everything by the same number, you still have the same equation. It's still perfectly valid, but it's more useful here because now the x's add up to 0. So we get 14y equals negative 14. So if we divide by 14, y equals negative 1. So after writing that transformation, or rewriting the entire system, the problem was pretty easy to get that first number, y equals negative 1. And I did this on purpose on this question. I wanted to show you sometimes you do solve for y first. Maybe that's the easiest one to solve for, so that's why I went ahead and did that. Now, how do we get that second number? We go back to one of the equations. It doesn't matter which one. You pick whichever one looks good to you, maybe has the smallest numbers, or maybe it has your favorite number in it, and you plug in. So negative 5 times, instead of writing y, I'm putting that negative 1 in there. That's called substituting a value in. And x plus 5 equals 4. We minus 5 on both sides. X equals negative 1. X equals negative 1. So there's our two coordinates for our point of intersection of the two lines. It happens to be at negative 1, negative 1. So that wasn't so bad, right, with this transformation. Sometimes you have what it's called a double transformation, and you have to multiply the second equation by a different number to make sure that something adds up to 0. I'm not going to do one of those examples here, but you could check out some of the other videos on my channel for some more examples on this. All right, good luck on solving systems. I gave you 4 methods that you could attack these problems with and maybe even check your answers. All right, until next time.